Good afternoon, dear participants. Let me congratulate you with the participation in this conference. Your presence here shows your interest in further development and exchange of ideas. Let this time that we spend together be full of inspiration and new knowledge. I wish us all a fruitful exchange of ideas and important discoveries. So now let me introduce myself. My name is Eduard Kliuiev. I am a senior researcher at the Polakov Institute of Geotechnical Mechanics of the National Academy of Sciences of Ukraine, the city of Dnipro. And let me introduce my scientific work dedicated to the analysis of quantitative and qualitative parameters of gas mixture in thermal processes of mine medium. The coal industry of Ukraine plays an important role in providing the country with energy resources and raw materials for industry, especially during a wartime. Currently, there is a very urgent need for coal as the main source of energy in war conditions due to the versatility of coal combustion technologies at thermal power plants. Here are the main advantages. First of all, it's a flexibility in responding the consumer needs. Secondly, the independence from external factors. And in thirdly, the simpleness of operation and availability. In general, the occurrence of fires of both endogenous and exogenous nature in worked area has become more frequent. Huge difficulties arise with the elimination of the fire consequences in mines where coal mining is carried out at the same time. In such conditions, it is not always possible to extinguish the endogenous fire by direct attack. The elimination of such fires can take tens of years, and complicate mining processes. The application of existing solutions for the prevention and spread of fires in underground tunnels is complicated by the problem of the air tightness of the isolated space and the management of the parameters of the mine atmosphere in it. The analysis of existing works has shown that thermal impact on the mine medium can take place both in an oxygen-free environment and with the use of oxidizers. These processes primarily involve the decomposition of the organic matter, the recombination of the splitting products, and the formation of the thermodynamically stable final substances, such as solid residue, the liquid products, and the gas phase. The physical essence of the thermal processes of coal is as follows. According to the Fuchs-Crevillon pyrolysis theory, the process can be accurately described as a sequence of chemical reactions involving the decomposition of organic matter occurred in the adjacent layer and in the outer surface of the particles. The goal of the study is to produce further information regarding the following question: what kind of gas should be produced during coal combustion in isolated space to identify signs of underground fire development? On this slide, you can see the methods that we try to use. First of all, you can see the table that represents the results of elemental and technical analysis of coal samples, which we use in our experimental installation. You can see also the scheme of laboratory installation for the study of coal combustion processes, which include electric furnace, thermocouple, galvanometer, receiving flask, vessel with cooling liquid, and others parts. According to the provided information, the laboratory installation could carry out an analysis and determine the quantitative content of the following components of the gas phase: carbon dioxide and hydrogen sulfide simultaneously, unsaturated hydrocarbons, oxygen, carbon monoxide, hydrogen, methane, and nitrogen. Here we can see the yield of combustible gases depending on process temperature. Calculating the heat of combustion, the following assumptions were made. Firstly, due to the small content of carbon disulfide, this gas was not taken into account. Secondly, the combustion of the gas mixture took place under normal conditions. Then we can see on the next slide the ratio of combustible components and heat of gas mixture combustion in relation to the amount of methane depending on the process temperature. According to this figure, the following conclusions can be given. In the temperature range from 400 to 900 Celsius degrees, with the increasing of temperature increases the gas mixture yield, and as a result, the head of its combustion according to this quadratic dependence. We can see here the dependence of the calculated combustion heat of the percentage fraction of each gas on the process temperature. So according to these researchers, at a temperature of 400 Celsius degrees, methane and carbon monoxide contribute the biggest fraction to the heat of gas mixture combustion. And the temperature 600 Celsius degrees, methane and unsaturated hydrocarbons. At the temperature of 800 degrees Celsius, hydrogen, carbon monoxide, methane, and at a temperature of 900 Celsius degrees, hydrogen, carbon monoxide, and methane. We can see some conclusions. The obtained statistical data indicate that the relevance and importance of coal mining and processing in Ukraine for the stable generation of electricity in thermal power plants. However, these processes are associated with numerous risks to the lives and health of miners, because in coal mines the working conditions are characterized by a significant number of hazardous factors. In general, the occurrence of fires of both endogenous and exogenous nature in worked out area has become more frequent. Huge difficulties arise with the elimination of the fire consequences in mines where coal mining is carried out at the same time. The analysis of existing works has shown that the thermal impact on mine medium can take place both in oxygen-free environment and with the use of oxidizers. These processes primarily involve the decomposition of the organic matter, the recombination of the splitting products, and the formation of the thermodynamically stable final substances. As a matter of fact, carbon, oxygen, and hydrogen, which are part of the molecular composition of coal, turned into methane, carbon monoxide, and water vapor. The following combustion gases are formed during thermal action on coal in air-free medium: methane, carbon monoxide, hydrogen, and unsaturated hydrocarbons. It was found that in the temperature range from 400 to 900 Celsius degrees, with the increasing of temperature increases the gas mixture yield, and as a result, the heat of its combustion according to the quadratic dependence. Methane yield increases up to a temperature of 600 Celsius degrees. Then its content in the gas mixture decreases. This can be explained by the decomposition of methane into hydrogen and carbon at high temperatures. These processes help to raise the amount of hydrogen in the temperature range. High values of combustion heat of the gas mixture in the temperature range from 400 to 600 degrees Celsius are achieved due to methane. When the temperature increases, the heat of combustion due to hydrogen and carbon monoxide rises. So, as a matter of fact, the obtained values of combustion heat of gas mixtures made it possible to establish qualitative and quantitative parameters of the thermal process. These data will be used in the future for the calculation of the thermal balance of the mine medium and modeling of the thermodynamic processes arising as a result of mine fires in the isolated space. Thank you for your attention. Have a nice day.